Like, it'll just happen. All right, logarithms. Day one, we're going to be doing this for 2 days. Maybe 3. So first we have to talk about what a logarithm is. A logarithm is the opposite of an exponential function. In math, everything really needs to have an opposite so that we can undo things when we're solving. Like, what's the opposite of addition?
Subtraction.
How about multiplication?
Division.
How about squaring something?
Square roots.
How about logarithm?
Exponents.
Exponents, okay? So if we're trying to solve a problem that looks like this with logs in it, or like, I'll show you what we'll be doing later. This is a common one. If you had a question like this that said 20 to what power equals 56? What's 20 to the first power?
22.
What's 20 squared?
400.
400. So it's definitely somewhere between 1 and 2. But otherwise, you'd just be guessing, right? You'd start being like, I don't know, 1.1, 1.2, 1.156, you know, and just start guessing. But a logarithm can tell you exactly what that answer is. So anytime there's a variable in an exponent is when you end up using a logarithm. All right. So I'm going to show you what I mean. Let's do something obvious that is not on this list. Okay, so 3 squared equals 9. Everybody agree?
Yes.
This is called the base. Over here we've got the answer. Up here we've got the exponent.
Wait, are we officially on unit 2 now?
We are in this is unit 4. If you want to line it up to a chapter in the book, 4. I don't think you need to do 3 at all. And 2 is all of the graphs that I'm going to hit at the end of the year. And 5 is trig. So I'm doing a little bit of 4 before we go on to trig. Okay? All right, 3 squared equals 9. Everybody agree?
Yes.
Okay, here's what a logarithm looks like. You write log. You put the base down here. It's like lower than the word log, like a subscript. You put the answer next to it. So log and 9 are like on the same level. And then over here is the exponent. So this is the base now. The answer is here. And this is the exponent. And it seems silly to have two things that do exactly the same thing, but then that's the same thing with multiplying and dividing, right? They just undo each other. They're just opposites of each other. So the first thing that we're going to start with is trying some of these. We're going to do some of them in our head, and then we're going to do some of them using a calculator. I'm going to show you how to do them. All right, so let's try, because this is your assignment, so I'm just going to do some of your assignment with you. Let's try number 21. All right, so this is the base, this is the answer. So actually, here's what it means. Everybody write it down. 4 to the what equals 64. What they're looking for right now is the exponent. Can anybody think of that answer? 4 to the what equals 64? Is it 4 to the 4 or 4 to the 3? 4 to the third power. Everybody try it in their calculator, right? 4 caret 3. 4 to the third power is 64. So the answer to this one is 3. How about this one?
2.
It's not what times 4 is 16. It's 4 to the what power is 16? 2. How about this one? 5 to the what power is 125? 5 to the third power. See how easy this is? Simple. All right, now let's do a harder one. it's true that 7 to the third power is 343, right? But 343 to the what power is 7?
1/3 or either -3.
Let's try it. All right, everybody take 343 in their calculator. 343. What was your first guess?
It's either 1/3 or -3.
Okay, let's all try 1/3. 343 to the power of 1/3. Remember to use the power key. It's that caret above the dividing sign. Why does that make sense? What is a 1/3 again?
Square cube root.
A cubed root, right? Like a square root would be 1/2. So like if I had 16 to the 1/2, that would be 4. Everybody understand? A cubed root is like a third root of that number. But what would it have been if it was this to the power of -3? Anybody remember what a -3 power was? What's a negative power? Yeah, it puts it on the bottom. If it was just to the -1, it would be 1 over 343, but instead it's 1 over 343 to the third power, which is something very, very small. Okay, all right, so this one is 1/3. And I'm going to jump over here. Let's try this one. 3 to the what power is 1 over 243. Don't do that thing where you're just finishing the problems and ignoring me and not paying attention to this one. 24. Okay, it's going to turn out to be a fraction with a 1 on top. So what do we know about the answer? What kind of power? Negative, but we need to know 3 to the what power is 243. Let's try 5. 3 to the power of 5. Oh, did you look it up? Nice. 3 to the power of 5, so this would be -5, because if it was 3 to the power of 5, it would have gotten positive 243. Now, I know that you want to just keep going and fill in all these answers, right? But this isn't due for a while, so stay with me and stop working. Please. Okay, go to the bottom right now. And I want you to do is this. Let's write one we know. Georgia, give me a power that we know. Everybody knows by heart. 7 squared is 49? Okay, so 7 squared is 49. So if I was going to write it as a log, what would I write? Log base 7 of 49 is 2. You know what? I'm going to write this out. Log, I would say log base 7 of 49, if I was going to say that out loud. Now, your calculator is in a certain base. Does anybody know what base calculators are in? Yeah?
Base 10, right?
Yes. Why is it base 10?
Because once our fingers.
Yeah. Do you guys know what it means to be in base 10? We got 2 people who know. Anybody else know what it means to be in base 10? It means that when we roll over numbers, like we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. Do you see how we roll over back to ones after 10? 21, 31, 41. It happens after 10, right? That means we're in base 10. And literally the reason why human beings choose to use base 10 is because we have 10 fingers. If we were aliens on a different planet and we had 3 fingers on each, we would probably go by base 6. And we would say 1, 2, 3, 4, 5, 6, 11, 12, 13, 14, 15, 16, 21, 22, 23, 24, 25, 26. You see what I mean? So it would always be going up to 6, rolling over at 6s. Instead, we're doing 10s. So your calculator automatically assumes that your logarithm base is 10. But there's something called the change of base rule. So first of all, we'll write this. We'll write that your calculator is in log base 10. This is your calculator. Your calculator is always doing base 10. So what would this answer be? Log base 10 of 100. 10 to the power of what makes 100? Nope. 2. 10 squared is 100. Everybody agree? So everybody type in right now, use the log button. The log button's next to the 7. Type in log 10. Oh, sorry, log, what'd I say, log 100? Do you see how there's no place to put the base in? You can only put the answer in. There actually is a place that you can go somewhere else where you can change it. There's also something called the change of base rule.